Hey, in this video, I would like to provide a very short review on the chapter Differentiation Rules. Okay, and then after that, I will solve some problems from practice test. Uh, so first thing I would like to remind you is the definition of the derivative. So the derivative is defined via limit. Okay, if this limit exists, means the derivative exists, and we call f is differentiable at that point. So uh, here we have limit. That means we need to consider the left limit and the right limit. Correspondingly, you would have the left derivative and the right derivative, right? Once you have the left derivative and the right derivative are equal, so you have only one derivative, or say the derivative exists. I just want to say about the left tangent line and the right tangent line. For example, for this function, you might have, this is the left tangent line, this is the right tangent line. So at this point, the left tangent line and the right tangent line are different. The function does not have tangent line, common tangent line at this point. Means the function is not differentiable. So in the practice test, we have one problem with this formula. So I go ahead to solve that problem right now, okay? And then we move to the next problems, and I do review different differentiation rules. First question, use this limit process to find the derivative of function f of x equal to x squared minus 3. Okay, that means we have to just use this limit. We don't have any room right now. Let's write f derivative equal to the limit of. You see, instead of x plus delta x in here, right? If I use this function, so here I would have x plus delta x squared minus 3. So that is f of x plus delta x. You see, I just instead of x in here, I use x plus delta x. So that's why I have x plus delta x squared minus 3 minus x squared minus 3 over delta x when delta x goes to 0. And now we have to find this limit. Okay, we have to find this limit, and you see, let's open parentheses. I will do in here. I just wouldn't have enough space. So I open this parenthesis. I open this parenthesis. I open this parenthesis. But here I need to change the sign. So that is plus. And then you see negative 3 and plus 3. This guy with this guy will be cancelled out, right? Will be cancelled out. So let me erase that outline shot. You just erase this guy. So I still have x plus delta x squared minus x squared. Now let's start with this. At this step, if you still remember, a squared minus b squared equal to a minus b times a plus b. So you can factor the top, right? Factor the top. The top is equal to limit x plus delta x minus x, which is a minus b times x plus delta x plus x over delta x when delta x goes to 0. So you see, x with negative x will be cancelled out, right? So in this factor, we have only delta x. So I write limit of delta x, x. And here you have x plus x is 2x, right? Plus delta x over delta x when delta x goes to 0. So now we cancel delta x and delta x in here. So delta x will be cancelled out. I have limit of 2x plus delta x when delta x goes to 0. And now you just plug 0 into this function, right? You have 2x plus 0, which is 2x. So that's how to find derivative using limit process or using definition. Alright, so that is the first problem. That would be a bonus question on the test. Alright, so let's talk a little bit about derivative, right? So we have derivative, that is limit of this, so we have just in here. But don't forget about derivative at some point, that is the slope, right, of the tangent line. That is the slope of the tangent line at x0 in here. Secondly, that is instantaneous rate of change, right? Or that is, instantaneous speed. That is three different meaning of the derivative. So it depends on how we can use that. Thanks to this, we have two problems with tangent lines. The first problem with the tangent line is find the equation of the tangent line, right? Just find equation of the tangent line. And let's repeat how to find an equation of tangent line. In order to have the equation of tangent line, we need the slope, right? We need the slope. But we see the slope is derivative, right? That means we have to find derivative, and then we plug that point x0 into the derivative to find the slope. And then the next step is you need to find the y coordinate, or sometimes you just plug 0 into the original function. So you have the y coordinate, right? And then once you have slope, when you have y coordinate, you can write the equation that's equal to m x minus x0 plus y0, where m is the slope. This is the slope in here. Okay, this is the first question with the tangent line. Okay, so find equation of the tangent line. The second problem with the tangent line is, let me erase this, is to find by x where the tangent line is horizontal. The tangent line is horizontal means the slope is 0. But what is the slope? The slope is derivative, right? So the tangent line is horizontal means the derivative at that point is 0. So we have to take derivative and then we set it equal to 0. And we need to solve for x. Okay? That is two tangent line problems in this chapter. Okay, now let's go ahead to finish all problems in this practice test. Let's say find an equation of tangent line. Okay, the function is f of x equal to x cosine of x minus sine of x, and x0 equal to pi over 2. So let's repeat what we just talking here, right? First step, slope. Y prime equal to, here we have product, we need to use the product rule, right? The product rule says f derivative derivative of root product is fg plus fg, and then I write derivative of f and then derivative of g. So in this case, f is x, g is cosine, right? Derivative of x is just 1 times cosine. Derivative of cosine plus, right, x. Derivative of cosine is negative sine. Okay, don't forget to use parentheses in this case. And derivative sine is plus cosine or negative cosine. See? And here cosine will be cancelled out, used to have x times negative sine, which is negative x sine x. in this place, if you forgot parentheses, you will get x minus psi, and of course that is the wrong answer. So from here, I can find the slope. That is just 1 prime when x equal to pi over 2. So I plug pi over 2 into this function. I have pi over 2 sine of pi over 2, which is negative pi over 2, because sine of pi over 2 is 1. Okay, we have slope. Next, we have to find the y coordinate. So I have y at pi over 2 is equal to, I plug pi over 2 into the original function. That is pi over 2 cosine of pi over 2 minus sine of pi over 2. You see, cosine of pi over 2 is 0. So this term is 0. Here I have 1. So here I have negative. That means this equal to negative 1. Now I can write the equation. Y equal to negative pi over 2 is the slope. X minus pi over 2, which is this, and then minus 1. This is the equation of the tangent line at pi over 2. Alright? So now let's move to the second problem with tangent line. Find x where tangent line is horizontal. F of x equal to 2x minus 1 over x squared plus 1. You see, here we have quotient, right? We need to use the quotient rule. Each time when you want to apply some differentiation rule, I very recommend you to write it down and just follow that. F over g derivative equal to, I write fg, here I write fg, and here I have g squared. Since this is quotient, in between them I get negative, right? And then I have f derivative and then g derivative. In this case, f is 2x minus 1 and g is x squared plus 1, right? So, so derivative of f is what? It's the derivative of this guy, which is 2. Let me write step by step, right? 2x minus 1 squared, not square, prime, times x squared plus 1 minus 2x minus 1 times x squared plus 1 prime divided by x squared plus 1 squared, right? So, since we need to find x where the tangent line is horizontal, that means we have to set the derivative equal to 0. Once you get this equal to 0, since this is fraction, so you only need to put the top equal to 0. So that means I don't need to take care about x squared plus 1 squared, right? I just put the top equal to 0. Now let's see what happened on the top. 2x minus 1 derivative is 2. X squared plus 1 minus, here is 2x minus 1. Derivative of this guy is 2x, right? Because 1 derivative is 0. So I have 0 here. And now let's distribute it. I have 2x squared plus 2 minus 2x with 2x is 4x, but with negative, I have minus 4x squared in here, right? And then negative 1 with 2x. 2x with the negative, it means I have plus 2x equal to 0. So overall, I have 2x squared negative 4x squared, that is negative 2x squared. 2x plus 2 equal to 0. Or you see 2, 2, 2, we can simplify that, right? So from here I get negative x squared plus x plus 1 equal to 0. That means in order to find all x where tangent line is horizontal, we need to solve this equation. This is quadratic equation, right? So we need to use quadratic formula. What's that? So let me erase this part, right? And let me write quadratic formula. For ax squared plus bx plus c equal to 0, x1 and 2 equal to negative b plus minus square root of b squared minus 4ac over 2a. So in this case, a is negative 1, b is 1, and c is 1. you plug A, B, C into this to get two solutions. If I don't ask you to find the y coordinates, so you don't need to, you just need to solve for the x. Okay? Alright, so I think that's all with two tangent line problems. Now let's work with power rule, right? In the rest, we need to find derivative. The first function is, let me divide the form. So I have f of x equal 2 times x to 10 minus x to 4 plus 1. Here we have power function. Here we have power function. So the power rule says that if you have x to p and you need to take derivative, you need to bring the power down, right? And then you reduce the power by 1, which is x to p minus 1. And that's it, right? So derivative of this function is equal to 2 times. This, I have 10 times x to 9, because 10 minus 1 is 9, minus 4, the power down, x to third, and then just 0. So I don't have anything in here. So you can simplify that, it's just 20x to 9 minus 4x cubed. Done. Alright? The next question, f of x is equal to 11th root minus 2 over x cubed. You know, we have radical function in here, and we have some kind of fractional, right? Rational or fractional functions in here. But whole functions can be converted into power functions. So for this guy, I will write that is just x to 1 over 11, right? And then here, I will flip that. I get 2x to negative 3. And now we have two power functions. We can apply the power rule in order to find their derivative. So f derivative in this case is equal to 1 over 11. Bring the power down, right? And then x to 1 over 11 minus 1. Minus 2 times negative 3. Don't forget to use parentheses. Here x to negative 3 minus 1. So if you want, you can simplify that. You get x to here have negative 10 over 11. Negative 2 with negative 3 is plus 6. And then x to negative 4. Okay? Now, let's work on the chain rule. F of x equal to sine of 2x squared minus x. So you see, I repeat again, right? This is not the product of two functions. This is not the product between sine and 2x squared minus 1. 2x squared minus 1 is the angle, and sine of this whole thing, of this whole angle. So if you pay attention, here we have two functions, right? The outside function is sine, and the inside function is 2x squared minus 2. So in order to find the derivative of this function, we need to use the chain rule. The chain rule. Chain rule says if you have the function f of g of x and you want to take the derivative of this, you need to evaluate derivative of f, right? And then apply to the g. After that, you multiply by the root of g. Okay? So for this function, f is sine and g is 2x squared minus x. By the chain rule, I have f derivative equal to, you see, I will take derivative of the sine. I don't care about this part. Derivative of the sine is cosine. I leave this blank, right? And then I look back. This is 2x minus 1. I use 2x minus 1 to fill this blank. Since this is the last function I use, I need to multiply by the derivative of this function. So I get 2x squared minus x derivative. You see, the chain rule. Derivative of the first function, evaluate it at the second, at the inside, and then multiply by the derivative of the inside. And now I just need to take the derivative of this, which is easy, right? I have 4x minus 1 multiplied by cosine of 2x squared minus x. That's it. Next function I want to solve is to find derivative by implicit differentiation. Okay. Suppose y is a function of x, and that function is given by the following equation. Looks like this. There's no way to solve y with respect to the x, so I have to use implicit differentiation. For implicit differentiation, first step we need to do is just differentiate both sides, right? Differentiate both sides. Let's say here we have product, but don't forget, I would like to remind you here. For example, y squared derivative is 2y prime, because y is a function of x. So when we differentiate such function, we need to use the chain rule. You see, 2 down, y reduced by 1, and then derivative of the inside. You see, in this case we have y to the 5. I have y 5 derivative is 5y to the 4, and then y prime. And now here we have product, right? We need to use the product rule in this case. So the derivative of this is 3x squared y plus x cubed y prime minus parentheses. Don't forget that. 2x y to 5, and then plus x squared 5 y to 4, and then y prime equal to 0. You see, that is the first step. When you need to use implicit differentiation, just differentiate both sides. And then the next step is you have to collect all terms with y prime, right? Collect them together because they have y prime, and we need y prime. So let me open this parenthesis. I open this parenthesis, right? You can write that in new line, but I don't have spaces, so that's why I do that here. So I open this, I change the sign here, right? I open this. Next, this term has y prime, this term has y prime. I collect them together. I have x cubed y prime minus x squared 5y to 4 y prime, right? And about this term and this term, I will bring them to another side. But when I do that, I need to change their side, right? For example, this guy, negative 2x y 5. I bring to that, I get 2x y 5. You see, I change the sign. And here I have 3x squared y, so I have negative 3x squared y. And since I have y prime is common, I factor that out. I have y prime x cubed minus x squared 5y to the 4 equal to 2xy to the 5th minus 3x squared y. And the next step is just divide both sides by this part to get y prime. That's it. You see? Very clear, right? Differentiate both sides, solve for y prime, and you know, I will not ask you to find a tangent line with implicit differentiation. So you can live with that. And the last question for this review is find the second derivative of the following function: y equal to x plus 2 over x minus 1. So in order to find the second derivative, we need to find the first derivative, right? The first derivative of this function can be found by using the quotient rule, right? quotient rule. So, but the quotient I have x plus 2, derivative x minus 1, minus x plus 2, x minus 1, derivative over x minus 1 squared. Derivative of x plus 2 is 1. Derivative of x minus 1 also 1, right? So I have x minus 1 minus x plus 2 divided by x minus 1 squared. Again, don't forget parentheses. Okay? And now you can open that. Let's open that. So you open this, but you have to change the sign here, right? So you have plus, you change this to minus. You have x minus x. X will cancel out. -1 with -3 is -3, right? X minus 1 squared. That is the first derivative. And then now, how to find second? You can find the second derivative using the quotient rule, right? But I hope that you still remember this form. So for this form, you can flip that. You might -3 and here the power -2. When you flip that, you get the following one. -3 times x minus 1 to -2. And now you can use the power rule to find derivative of that function, right? It means the second derivative of this guy. From here, I get y2 prime equal to -3 times -2. Bring the power down. And then reduce the power by 1. You get x minus 1 to -3. Or that is 6, because -3 with -2 is 6. X minus 1 to -3. Yeah. And that's all about the practice test. So I hope that this video is helpful for you. See you.